Okay, so this is a key to the worksheet where we have to solve quadratic inequalities. And make sure you read the directions as always. It says show all work as presented in class videos. Make sure you show the table with the critical points and whether the intervals are positive or negative. Make sure you show which test point you're using as presented and write the solution in interval notation. So you have to follow directions if you want to get all these points. So look at number 1. So when solving a polynomial inequality, and in this case these are going to be quadratic, you want to make sure that 0 is on the other side. And so once 0 is on the other side, the next step is to factor this polynomial. So all of ours will be factorable. So when I factor this, I get x minus 6 times x minus 3 is greater than 0. All right, once you factor, remember the whole point on this though is to find the values of x that will make this left side greater than 0. That's what you're trying to find. What values of x will make the left side, this polynomial right here, this quadratic polynomial, greater than 0. Okay? So you're trying to find those solutions. Okay, so first thing you're going to do is you're going to find your critical values or your zeros. So find critical values or zeros. They're called zeros. Okay? And to find those zeros, you're going to set this quadratic, either this one or this one. Make sure you use a factored one though. That's easier to deal with. So you're going to set the factored part equal to 0, and they're going to solve this equation. So you're going to use the zero factor property. So x minus 6 equals 0, x minus 3 equals 0, so x equals 6, x equals 3. So these are your zeros. Those are your zeros, are your critical values. Once you find your zeros, you put those on the number line. Okay? You put those on the number line in order. So 3, 3, and 6, right? 3 and 6. So you put those on the number line. Okay, now the next thing is to notice that those zeros divided the number line into 3 intervals. That's what that says. From -infinity to up to 3, from 3 to 6, and from 6 to infinity. Okay? So those zeros divided the number line into 3 intervals. What you're going to do is determine which of those intervals, and if possible, whether those zeros are solutions to this inequality. So remember what he said earlier. The solutions are the real numbers for x that will make this side, those are identical, equivalent, that will make this side greater than 0. Well, this side greater than 0 means you want this product here to be positive. That's what we mean by greater than 0. Any number greater than 0 is positive. Okay? And so you got to determine which of those intervals will make this side, this expression, positive. All right? Okay, now before we go on, you see that 3 and 6? 3 and 6 are never going to be a solution here because there's no equal sign. So when you substitute 3, you get 3 minus 3, that's 0. 0 times this is 0, and 0 is not greater than 0. So, and the same thing for 6. So you're going to put open circles here to indicate that those are not going to be solutions. If there was an equal sign, you would put closed circle because 3 and 6 would this time be solutions if there was an equal sign. So that's something you have to consider as well. Okay, now to determine which real numbers will make this positive, you're going to use test points. So that's one part of the directions is to indicate your test point. And we're going to indicate the test point using parentheses. So give me a number that's in that first interval. Any number. Any real number. It could be decimals, fractions, integers. Whenever possible, though, try and use integers. It makes things so much easier for you. So do y'all see, though, that 0's in that interval? So I'm going to use 0. I'm sorry. Yeah, 0's in that interval, right? So I'm going to use 0. And then in the interval from 3 to 6, what's another test point? What's another real number you can use in that second interval? Now, try and use an integer. So the only integer available would be 4 and 5. All right, so let's use 5. Over here, from any number greater than 6, let's use 8. 8's in there. Okay, so we're going to test those test points in the expression to see if that interval is going to be will make this positive or not. If this interval, if any real number in this interval is going to make this expression positive, if any real number in this interval will make this expression positive, and if any real number in this interval will make this expression positive. That's what I'm trying to find out. So there's where the test point comes in. So let's kind of do the work here. So and always go back to the factor to make things so much easier, but you got to make sure you factor this correctly. All right, so you're going to go here or here. It does not matter, by the way. So if you use a test point 0, where we see the variable x, and you substitute 0. So you're going to say this. You're going to say 0 minus 6 times 0 minus 3. That's what that says, right? Well, 0 subtract 6, and all you're looking at is just a sign. That's a negative number. 0 minus 3 is a negative 3. That's a negative number. A negative times a negative is a positive. So that means that any real number from negative infinity to 3, up to 3, will make this a positive number, and that's something you want. So that's going to be a solution. That interval is going to be a solution. Then we go to 5. You do the same thing. You go to always go to the factor part. Makes things so much easier. 5 subtract 6 times 5 subtract 3. 5 subtract 6, 5 subtract 3. 5 subtract 6, that's a negative 1, so that's negative. 5 subtract 3 is a positive 2, so that's positive. And put positive here. Positive. A negative times a positive is a negative. So what that means is that any real number between 3 and 6 in that second interval will make this expression on the left side a negative number. But that's not what I want. I want this expression to be a positive number. Okay? And by the way, see how I use the factors? If you had used the original, you just have to be careful. So you would say 5 squared minus 9 times 5 plus 18. So it's a little bit more work, because you actually have to figure this whole thing out. So you would need to use your calculator. So that's why it's always easiest to use the factored part for this to determine whether it's positive, negative, or positive or negative. All right, because all you're doing is just looking at the signs. Here you have to actually look at the value of each term in that expression. So 5 squared is 25. Yeah, you have to do the whole thing. Minus 9 times 5 is 45 plus 18. So then you're going to say 25 minus 45 plus 18, which is negative. So you have to do that whole thing to determine that. Okay? It's easier to use the factored part because you're just looking at the signs. All right. 8, same thing, right? 8. So you're going to say 8 subtract 6 times 8 subtract 3. 8 subtract 6 is a positive 2. 8 subtract 3 is a positive 2. A positive times a positive is a positive. So that means that any real number that's greater than 6, any real number greater than 6 will make this left side positive. And that's what I want. I want that left side to be greater than 0. I want it to be positive. So that's going to be a solution. So you're done. You just indicate the answer now. So the interval notation, your solution, the solution. So any real number between negative infinity to 3, negative infinity to 3, with parentheses, union, and then 6 to infinity is a solution. Okay, so that's number 1. That's all you do. That's how you can do this problem. Okay, number 2. So in number 2, we have this for number 2. All right, number 2. All right, we have, let's see, it's x squared plus 3x is less than equal to 10. All right, so remember whenever you're using this approach, the positive, negative, positive, you got to make sure that zero's on this side. All right, so you have to make sure zero's on that other side. It's not here, so you got to bring that 10 over. So so your work, first thing you're going to do is going to say x squared plus 3x minus 10 is less than or equal to 0. All right, so now, since that's less than or equal to 0, you can now very easily use positive, negative to determine which intervals are going to be solutions to this original inequality. Okay? All right. So let's go ahead and factor first, or next. And so when I factor this, I'm going to get x plus 5 times x minus 2, and that's going to be less than or equal to 0. All right, now I've got to find my zeros, or my critical values. So to find your zeros, you're going to set this equal to 0. So x plus 5 times x minus 2 is equal to 0. And remember, that's some textbooks will call this your critical values. So x plus 5 is equal to 0, x minus 2 is equal to 0, so x equals negative 5, x equal 2. So those are your zeros, are your critical values. So you put that on the number line. Make sure you put them in order, negative 5 and then 2. And so now the next step is to notice that these two zeros divide the number line into intervals, 3 intervals. Negative infinity up to negative infinity up to negative 5, and then negative 5 to 2, and then the interval greater than 2. All right, so before we go on, though, let's determine if those two zeros are actually be solutions. So notice there's an equal sign. So if you substitute 2, for example, 2 minus 2 is 0, 0 times, and then 2 plus 5 is 7. 0 times 7 is 0, and 0 is less than or equal to 0. It's equal to. So those are both going to be solutions. So you're going to put a closed circle there because of the equal sign. So when you do the interval, you're going to put a bracket instead of parentheses like we did here. Okay, so now let's pick some test points. So give me a number between a real number, and let's use an integer if possible, between negative infinity and negative 5. So let's say negative 6. Between negative 5 and 2, 0 is always the easiest to use. And then greater than 2, let's use 3. Okay? So those are my test points. Now, you're going to put those test points into the factored part. So that's x plus 5 times x minus 2. So let's do negative 6 next first. Negative 6 plus 5 times negative 6 minus 2. Negative 6 plus 5 is a negative 1. That's a negative number. Negative 6 and negative 2 is a negative 8. That's a negative number. A negative times a negative is a positive, right? So that means that any real number between negative infinity up to negative 5 is going to make this left side a positive number. Okay, is that something I want? Do I want that left side to be positive? The answer is no. I want that left side to be less than 0, meaning negative. So I want this to be negative or equal to 0. So the 0, that's this little part here. That's the closed circle. All right, so that's where we closed it. All right, so I'm trying to find the negative next. So that's positive. Let's do 0. If x is 0, I get 0 plus 5, 0 minus 2. 0 plus 5 is positive. 0 minus 2 is negative. A positive times a negative is a negative. So that means that any real number in that second interval between negative 5 and 2 is going to make this left side negative, which means is going to be a solution to the original. Okay, so the solution to the original will be, so far, any real number between negative 5 and 2, including negative 5 and 2 because of the bracket. And then for 3, let's see what happens there. 3 plus 5, 3 minus 2. 3 plus 5 is positive. 3 subtract 2 is positive 1. That's positive. A positive. See how those two factors will be multiplied together. So a positive times a positive is a positive, which means that any real number that's in this interval greater than 2 is going to make this left side positive, but I want it to be negative. So it's not going to be a solution to the original. So the only solution is this one. So my answer, you're going to say bracket negative 5 to 2 with a bracket. All right, so notice the work. Notice the work. That's what you had to do. All right, number 3. So let's do number 3. So in number 3, let's see, we have this. for number 3. All right, here's number 3. So we have x squared is less than negative 6x minus 8. So I want to find all real numbers that will make this side less than this side. Looking at this is pretty difficult, right? So that's why we have to use this analytical approach here. That's why we have to do this. Do it that way to find out what the solutions are. Okay, so I'm going to bring all the terms to the other side because I need 0 here. So here's the work. You're going to say x squared plus 6x plus 8 is less than 0. Okay, now we're going to go ahead and factor this. So remember, all of them are factorable. So when I factor this, I get x plus 4 times x plus 2 is less than 0. So now we're going to find those zeros. So let's find out what makes this 0. So those will be your critical values. So we're going to say x plus 4 times x plus 2 is equal to 0. And I'm going to solve for x. So x plus 4 equals 0. X plus 2 equals 0 using the zero factor property. So x equals negative 4 and x equals negative 2. So those are your zeros. Those are your critical values. So now you're going to put this on the number line. All right, on the number line. Make sure you put them in order. Negative 4 is less than negative 2. And first of all, let's determine, are those zeros going to be solutions to the original inequality? And the answer is no, because there's no equal sign. All right, so right away, we're going to put open circles there. So those are not going to be your solutions. So you're not going to put those as a bracket. All right, so now let's find some test points. So remember, those two zeros divide the number line into 3 intervals. So you got to check those intervals to see if they're going to be solutions. Notice though, I want whatever interval works, whatever interval solution, you got to make sure that those real numbers makes this left side less than 0, meaning negative. Any number that's negative is less than 0. So the test point, let's say in this case, let's use negative 5. Over here in that interval, there's only one integer. So let's use it. It's negative 3, right? There's only one integer to use. And over here, let's use 0. And so let's go ahead and substitute now. So we're almost done. We're more than halfway done with this problem. Always go back to the factored part. Makes things easier for you. Negative 5 plus 4 times negative 5 plus 2. Negative 5 plus 4, that's a negative 1, so that's negative. Negative 5 plus 2 is a negative 3, so that's negative. A negative times a negative is a positive. So any real number in that first interval will make these two inequalities here, these two expressions right here that I'm pointing to, a positive number, but that's not what I want. So those real numbers here will not be solutions to the original inequality. Let's go to the next one, negative 3. So I get negative 3 plus 4 times negative 3 plus 2. Negative 3 plus 4 is a positive 1. Negative 3 plus 2 is a negative 1. A positive times a negative is a negative, right? So that's negative. So what that means is that any real number that's in that second interval will make these two expressions negative, which is what I want. So any real number in that interval will make the original inequality a true statement. All right, so that's going to be a solution. If I do 0 next, 0 plus 4, 0 plus 2. 0 plus 4 is positive. 0 plus 2 is positive. A positive times a positive is a positive. And that's not going to be a solution because I want it to be negative. So my solution would be any, so this is your answer. Your solution would be any real number between negative 4 and negative 2. All right? And let's just check this. I just want to show you how to check this real quick. So let's just check it. And we're going to check one number in here, okay? Let's check one number in here. And there was only one integer in there, negative 3. So let's go ahead and use let's check negative 3.5. So negative 3.5 is in here, right? So let's see why negative 3.5 is a solution. So here's the question. So for number 3, why is negative 3.5 a solution? X equal negative 3.5 a solution. So let's go back to the original. And when I say original, I mean this, okay? So in place of x, I'm going to substitute negative 3.5. So I'm going back to the original. So I get negative 3.5 in parentheses because it's negative, it's being squared. And I want to see if that's going to be less than negative 6 times negative 3.5 minus 8. You're going to have to use your calculator. So negative 3.5 squared in parentheses, negative 3.5 squared is a positive 12.25. So that's this side. So I want to see if 12.25 is less than, and then let's figure out this one. Negative, look what I'm doing now, okay, so be careful. Negative times negative 6, look, negative 6, got to be careful, times negative 3.5, right? And then subtract 8 equals 13. So is 12.25 less than 13? The answer is yes. So that's a solution. And real quickly, let's pick a number that's not a solution. So let's say 6. 6 is not in here, right? 6 is on the outside. So let's see why 6 is not a solution. So why is x equals 6 not a solution? So go back to the original. Now when I say the original, I mean the original problem, the one before you got 0 on one side. So x squared minus 6x is less than negative 6x minus 8. So x squared is less than negative 6x minus 8. So in place of x, I'm going to substitute 6. So 6 squared, and we'll see that's going to be less than negative 6 times 6 minus 8, right? 6 squared is 36. So is 36 less than a negative 6 times 6 is a negative 36 minus 8, and a negative 36 and a negative 8 is a negative 44. So is 36 less than a negative 44? The answer is no, right? That's a positive number. A positive number is always bigger than a negative number. So that's why x equals 6 is not in this solution, because it's not a solution. All right, so I just wanted you to see this. And then finally, number 4. So it's very simple. Very simple. As long as you did the directions, you should be fine. Always follow directions. Make sure you're studying the lessons. Don't go directly to those worksheets. Always study the lessons before going to those worksheets. So the next one is 3x squared plus 11x minus 4 is greater than or equal to 0. So we're going to have 0 on this side. So we got to factor this quadratic polynomial. So let's go and do this. So there's the work. So when I factor this, I'm going to get 3x minus 1 times x plus 4 is greater than or equal to 0. Okay? And so now we've got to find the zeros. You can find your zeros. So we're going to set this equal to 0. 3x minus 1 times x plus 4 is equal to 0. So we're going to solve this equation by using the zero factor property. So 3x minus 1 equals 0. X plus 4 equals 0. So for this one, for this linear equation, I'm going to get x equal 1/2. For this one, I'll get x equal negative 4. So those are your zeros. All right, so those are the zeros. So we're going to put that on the number line in order, negative 4, and then 1/3. And so first of all, let's ask ourselves, are those zeros going to be solutions? And the answer is yes, because that equal sign. So if I substitute both of those into the left side here, this side is going to be 0, and 0 is equal to 0. So I'm going to put a closed circle on both. So both of those are solutions. I'm going to use brackets for them. Okay, so now I got to find some test points. So a test point in that first interval will be, let's say, negative 5. A test point in that second interval is 0. So let's use 0 because 0 is always easy to use. And in a real number greater than 1/3, let's use 1. You can use any real number you want to. You'll get the same sign for that interval. So where we see the variable x, I'm going to substitute negative 5. So I get 3 times a negative 5, okay, 3x, so 3 times a negative 5 minus 1 times negative 5 plus 4. 3 times a negative 5 is a negative 15, and negative 15 and negative 1 is a negative 16, so that's negative. Negative 5 plus 4 is a negative 1, that's negative. A negative times a negative is a positive. So what I found is that any real number in that interval from negative infinity up to negative 4, or less than negative 4, is going to make this left side positive. Is that what I want? Yes, I do, because I want whatever real numbers is my solution, I want that expression here to be greater than 0 or equal to 0. So meaning positive or 0. And I already took care of the 0 with the brackets. Okay? So that's going to be a solution because I see positive here. The next one, 0. The test point 0. So you're going to, wherever you see the variable x, you're going to substitute 0. So you get 3 times 0 is 0. So I get 0 minus 1 times 0 plus 4. 0 minus 1 is negative 1. 0 plus 4 is a positive 4. A negative times a positive is a negative. Is that a solution? The answer is no, because any real number here is going to make this expression negative, and I want it to be positive. And then finally 1, if x is 1, I get 3 times 1 is 3. So I get 3 minus 1. And then when x is 1, I get 1 plus 4. 3 minus 1 is a positive 2. 1 plus 4 is a positive 5. A positive times a positive is a positive. Is that going to be a solution? Is any real number in that interval going to be a solution to the original inequality? The answer is yes, because this will make this positive, which is what I want. So your answer, you're going to say negative infinity to negative 4 with a bracket because of the closed circle. And remember, when you're indicating negative infinity, infinity, that's always parentheses. So make sure it looks like a parentheses, make sure that looks like a bracket. And then union, and then bracket 1/3 to infinity. And so that's the work. That's the work you had to show if you wanted full credit. Because the directions said, and always follow directions, directions said, make sure you show the critical points and intervals, and which intervals are positive or negative. Okay? All right, so that is the key to this worksheet.